Yeah. So now, in this, so we have seen what does it mean by vacuum and what does it mean by vacuum analyze and what is the purpose of analyze and what is the purpose of vacuum. Now there is another topic called vacuum full. So the purpose of vacuum or vacuum full is one and the same, which means the purpose of vacuum or vacuum full is to remove the dead tuples. Now we see the difference between what does it mean by vacuum and vacuum full. Okay.
Okay.
And vacuum full. So whenever we perform vacuum, right? So it is going to remove the dead tuples. When it is going to remove the dead tuples, some space will be released back, right? So
Yes.
the only difference between the vacuum and vacuum full is in the context of space. Okay, in the context of space only. So whenever you perform any vacuum operation, dead tuples will be removed and space will be released back. Okay. So in case of vacuum, the space will be released back to the table. Space will be reclaimed. Space will be reclaimed at
Table level.
table level, and which will be used for the future inserts and which can be used for the future inserts on the same table. Future inserts on the same table. So whenever you perform any vacuum operation, the reclaimed space, the space will be reclaimed at the table level. And so when we release the space back to the table, so whenever you are going to perform any inserts on the same table, that reclaimed space will be used. Okay. In case of vacuum full, space will be released back to the space will be released back to the OS operating system. Okay, this is the main difference between vacuum and vacuum full. And the second difference is we don't need downtime.
Okay.
We don't need downtime. This is a online operation. Whenever you perform vacuum operation, so if someone else, okay, if someone else is going to access the same table, then nothing will happen. Okay, it will not disturb the existing vacuum operation. But what happens, right? Vacuum full, vacuum full needs, okay, vacuum full needs exclusive lock on the table. Okay,
Okay. Even
exclusive.
the reads won't be performed, right?
Yeah. Exclusive lock on the table. Okay, if someone tries to access the same table, then we will be seeing the blocking
Blockings.
sessions in the database. Blocking sessions in
Okay.
the database. Okay, the main difference is in the context of space and in the context of availability. Whenever we
Okay.
perform any vacuum operation on the table, okay, the space will be reclaimed at the table level. Okay, and
Okay.
the same space can be used for the future inserts on the same table. So whenever you perform vacuum full operation, the space will be released back to the operating system and it. Okay, and one more thing is vacuum full needs a exclusive lock on the table. So whenever you perform, if you want to perform any vacuum full operation, then you need a downtime. Okay, then you should ask for the downtime, because if someone tries to access the same table, then we will be seeing the blocking sessions on the database. Okay, which we will be seeing the blocking sessions on the database. To avoid these blocking sessions, if someone asks you to perform a vacuum full, then we will say like during this time vacuum full operation, no one should connect to the database and no one should at least access the object on which we are going to perform the vacuum full. Okay.
Okay.
So this
One doubt.
yeah.
Yeah, like in vacuum, when we are performing the vacuum, once the dead tuples has been removed, right, at table level,
Hmm.
so that space will be in unordered space, unordered level, right? Suppose that blocks will be in unordered level, right? It's not,
Yeah.
the data will not be fragmented, right? How can it be reused after fragmentation only? We can use the space, right?
Oh, no, no. It can be released. The space will be released. Though it is in unordered, though it is in, yeah, that is a fragmented space only, but we can reuse this fragmented space.
So the data is going to insert in that empty blocks.
Yeah. Insert in the empty bag. That's what I said, right? It can be used for the future inserts.
Okay, even it's in unordered level.
Yeah, it is in unordered only, unordered also. The space will be used for the future inserts. That is the reason why when I say the vacuum, a vacuum will release the space at the storage. I mean, like table level only. So
Level, yeah.
if we are not able to, if we are not vacuum full, right, we rarely perform the vacuum full because vacuum full needs a downtime, right? So
Yeah.
if vacuum is not going, if the space, whatever the space that is released by the vacuum is, if we are not able to use it, no, then there is no purpose of performing the vacuuming, right? Though it
Yes,
removes the dead
yes.
to pull, as you said, if the fragmentation is there, if the fragmentation is there, then also the time it will take to scan the thing increases, right? Scan the table increases, no?
Yes, yes.
Yeah. So the space, whatever the space that is released back, that can be used by the future, that can be used for the future inserts on the same table.
Okay. So whenever
Okay.
insert is going to happen, initially it's going to check the empty pages, and then if there is
Yeah.
any empty pages, then it's try to insert on the empty pages first.
Yes, yes, yes.
Okay, okay, got it.
Yeah. So with this we have completed the vacuum and vacuum. Now we'll be back to our original topic. What is the topic? Auto vacuum work memory.
Yeah.
Right? There we have started. Okay. Auto vacuum work memory. 1 minute.
Okay.
Auto vacuum work memory. So so now you got the idea about what does it mean by vacuum, what does it mean by analyze, what does it mean by auto vacuum, and what does it mean by auto analyze. Okay.
Yeah.
So who is going to perform auto vacuum operations? So auto vacuum operations are performed. Okay, auto vacuum operations are performed using a process called auto vacuum workers.
Okay.
Auto vacuum worker is a process. Auto vacuum worker. The auto
It's a
vacuum
background
worker is,
process, right?
yeah, yeah, yeah. Auto vacuum worker is responsible for performing. Auto vacuum worker is responsible for performing auto vacuum operation. Auto vacuum operations. Okay. How many auto vacuum workers will be created? How many auto vacuum workers will be created is based on a parameter called auto vacuum underscore max underscore workers.
Okay.
Auto vacuum underscore max underscore workers. So the default value is 3. By default, 3 auto vacuum workers will be there. Okay. Auto vacuum worker is a process which is responsible for performing the auto vacuum
Auto vacuum.
operation. Yeah. How many auto vacuum workers will be created? This is depending upon a parameter auto vacuum underscore max underscore workers. Okay. So
Okay.
each auto vacuum worker. Okay. And what is the parameter related to auto vacuum work memory? Auto vacuum underscore work underscore mem. Auto vacuum underscore work underscore mem is a parameter uh, with which we can define the auto vacuum work memory. Okay, each auto vacuum worker. Okay, each auto vacuum worker will be assigned with the value that is defined using auto vacuum work memory to perform this auto vacuum and auto analyze operations. Is this clear? So
Yes.
in Postgres, auto vacuum operation is performed by using a auto vacuum workers. Okay,
Okay.
auto vacuum workers. Each auto, how many auto vacuum workers will be created? It is depending
Like
upon a parameter auto vacuum underscore max underscore workers parameter.
workers parameters.
Each auto vacuum worker will be assigned with the value that is defined using auto vacuum work memory to perform this auto vacuum and auto analyze operations. Got it?
Yes. Is there any default memory allocated to this?
Yeah, that we will be discussing in the next parameter.
Okay.
Okay, the default value for the auto vacuum work memory is the default value for this auto vacuum work memory is -1. Why it is -1? We'll be discussing in the during the next memory area, which is like maintenance work memory. Okay.
Okay.
Okay. Now the next and the last memory segment, local memory segment is maintenance work memory.
Okay.
Maintenance work memory. So what is the parameter related to maintenance work memory is maintenance underscore work underscore mem. Maintenance underscore work underscore mem is a parameter. And what is the default value? The default value is 64 MB. The default value is 64 MB. And so what is the purpose of this maintenance work memory is what are the different maintenance operations that we have in Postgres? Maintenance operation. What are the different maintenance operations that we have in Postgres? We are having, so auto vacuum is performed by system. Whether
System.
vacuum
Yeah.
is a maintenance operation or not.
Yes.
Yeah, analyze.
It's also auto analysis a maintenance operation.
Analyze is a maintenance operation because we are going to perform this. Auto analyze is going to performed by system.
System. Yeah.
Yeah. So, and one more thing is creating index.
Okay.
And creating FKs, which means FKs means foreign keys.
Foreign keys. Okay. Okay.
Yeah. So these are the different maintenance operations that we are going to perform in Postgres. So, okay. So if you want to perform any of these operations, these operations will make use of this
Maintenance work memory.
work memory. Okay, these operations will you make use of this maintenance work memory. And one more thing, there is a relationship between maintenance work memory and auto vacuum work memory. If auto vacuum underscore work underscore mem equal to -1, then each then what happens, right? Worker then each auto vacuum worker will be assigned with the value that is defined using maintenance work memory. Now you got the difference, right? Why auto vacuum work memory is -1? Why auto vacuum work memory is -1, right? If the auto vacuum work memory parameter is -1, then each auto vacuum worker will be assigned with the value that is defined using maintenance underscore work underscore mem. Is that clear?
Okay. So actually, we have the max workers which is configured at auto vacuum, right?
Yes. No, you got it. You
Okay.
have taken it in
Memory.
the wrong
Okay.
way.
This
Yeah.
memory is depending on the maintenance work
Uh-huh.
memory.
Yeah,
Okay.
yeah.
Got it. Got it.
If the value of auto vacuum work memory is -1, if the value
Okay.
of auto vacuum work memory is -1, then each auto vacuum worker will be assigned with the value that is defined using maintenance underscore work underscore mem.
Okay. Okay.
Got it
Got it.
right?
Got it. Yes.
Yeah. So
So if
now
the
one more thing.
default value is 64 MB of maintenance
Yeah.
worker memory, then each
Uh-huh.
worker of auto vacuum
Uh-huh.
will allocate 64 MB.
Yeah, 64 MB for its operations. And so as a DBA, okay, you are a DBA, right? So as a
Mm.
DBA, if you get a request, if you get a script to create index, okay,
Okay. Okay.
if someone raises a change request to create an index, or if someone asks you to run a vacuum operation, okay. So as
Okay.
a DBA, your thought process should be how fastly we can complete this.
Yeah.
Okay, this creating a developer can also perform this creating index operation, and if he has the privileges, will the developer be able to perform the create index or not?
Yes.
Yes, and if the user has an access privilege, will he be able to perform the vacuum operation or not?
Yeah.
Yeah, but why does they are considering DBA, right? whenever you get this kind of request, you should always think that how fastly we can complete these operations. That's where yeah, it makes the difference between the DB and developer, right?
Yes.
Yeah. So if you think logically, so for creating a index or for performing a vacuum operation, which area is used?
Like
What is the
shared
memory area that is
memory.
being used?
Shared
No. What is
memory.
the memory area? What is the memory area that is being used for the vacuum or creating index?
Okay,
Maintenance work
local.
memory, right?
Yeah,
Maintenance work
maintenance
memory.
work
So
memory. Yes.
what we can do it whenever we get this kind of request, we can increase the maintenance work memory at session level. How can we do that? Set
Okay.
maintenance. So whenever you change any parameter at session level, will that be valid till that session or will that be valid till our entire system?
No, it's at session level only.
Yeah. Once we get disconnected from the session, this will be
Like
return to the
this will be
this will be
freed up.
return back to the
Yeah.
default value, right?
Yes. Yeah.
Set maintenance underscore work underscore mem equal to I'll keep 1 GB
Okay.
and I'll run this create index statement and vacuum operations. So the creating
Okay.
index and vacuum operations will be faster. Once the session is disconnected, anyway, it will be returned back to the default value.
Default
So
value.
so when if someone asks you when you're going to explain about this maintenance work memory, if someone asks then you can say like whenever we get a request to creating an index or performing a vacuum operation to make these operations faster, what we will do, right? We will increase this maintenance work memory at the session level and we will perform these operations. Then then these operations will be faster. That's what you
Little
need to say.
faster.
With this, we
Okay.
have completed the memory based architecture.
Memory. Okay.
Yeah. So
Yeah.
now the last topic is process based architecture. Okay.
Okay.
In the
Okay.
process based architecture, we have covered most of the process as of now, if you remember.
Yes.
Okay.
Yes. Yes.
Yeah. Process based architecture. Okay, process-based architecture. So the process-based architecture is divided into two parts. One is like Oracle only mandatory background process,
Yeah. Optional.
mandatory background processes. Second one is optional background processes. One is mandatory background process, and second one is a optional background process. What are the mandatory background process we have? We have a BG writer,
BG writer, val writer, check
val
pointer,
writer, and check pointer.
log writer.
Log
Is
writer
this
and val writer both are same, no? Yeah, that is different. Logging collector.
different? Yeah, it writes like logs into error log
Yeah.
files, right?
So the background processor, BG writer, validator, and checkpointer. Coming to the optional background process, we have archiver and
BG
stats
worker,
collector. Yeah, no. Stats collector. And third one is logging collector.
logging.
Yeah, logging collector.
Okay.
And fourth one is auto vacuum launcher.
Oh, auto vacuum is also optional.
Yeah, optional. By default, it is enabled, but it is an optional. If you want to disable, you can disable it.
Okay.
Okay, but by default it is enabled. Okay, so this is the process based architecture. Okay, the entire process based architecture we divide into two parts. One is mandatory background process and optional background process. Coming to the mandatory background process, we have a BG writer, val writer, and checkpointer. Coming to the optional background process, we have a archiver, stats collector, logging collector, and auto vacuum launcher. Now we will be discussing one by one. Okay, it is pretty easy only because we have already discussed. Okay, now let's discuss about the BG writer.
Yeah, it writes all the data which is there in the
Yeah,
buffer cache.
BG writer
I
writes
mean shared
BG
buffer
writer writes
to
data. Yeah, BG writer writes data from dirty data from
yeah, dirty
BG writer
buffers.
writes dirty data from shared buffer to the disk.
Disks.
When it is going to write, it is going to write in the event of commit
Check
or
pointer occurs.
or 1/3 of the shared buffer is filled.
Filled or yeah. Is there any time limit like for every 3 seconds like that?
Yeah, I think it is there. That I'll check and let you know. Okay.
Okay.
So BG writer is responsible for writing the dirty data from shared buffer to the disk in the event of commit or check pointer. 1/3 of the shared buffer is filled.
Filled.
Okay.
Yeah.
So now when we say dirty data, what does it mean by a dirty data? Dirty data is nothing but data which is modified. Data which is modified but not yet
Committed. Okay.
written to
Return
disk.
to the disk.
Yeah. Dirty data is a data which is modified but not yet written to the disk. That data we call it as a dirty data. So what background writer will do, right? Background writer spends most of its time in the sleeping mode only. Okay. Whenever it
Okay.
wakes up, it will go to shared buffer and scans for the dirty data. Okay. If it finds any dirty data, it will pick the dirty data and it will return to the disk.
Disk. Yeah.
Okay.
Okay.
Yeah. Now the second is val writer. Okay.
Okay.
Val writer. Okay. Val writer writes val data. Val data from where to where? Val buffer to
Val
the
buffer to the val files.
val buffer to the val files. Val buffer to the val files. So where these val files are going to store? Val files are going to get stored in a directory called pg underscore val. What is the location of the pg underscore val directory? Okay. So where these val files are going to get written? These val files are going to get written into a directory called pg underscore val. If you want to see, so let me go to the data directory. Okay, let me go to the data directory here. What is the data directory in my configuration is cd/u02 Postgres data directory. Under this, there is a directory called pg underscore val. Okay, let me go to pg underscore val. Okay, these are the val files. Okay, these are the val files. So these are the val files. Okay, val files are going to return to a directory called pg underscore val. If the version of the Postgres is greater than 10, if the version of the Postgres is greater than 10, then we are calling it as a pg underscore val. If the version is less than 10, then we use it to call it as a pg underscore xlog directory. The directory name is renamed as pg underscore
Val.
xlogs to pg underscore val. Okay, val buffer is a val writer is a process which writes val data from val buffer to the val files in the pg underscore val location. Val files are also called as a val segments. Val files are also called as what?
Val segments.
Val files are also called as what? Val segments. Okay, now the next topic is check pointer. Okay, check
Okay.
pointer. Now the next topic is check pointer. So what check pointer will do? Whenever checkpoint happen, check pointer sends a signals to val writer. Okay, whenever check pointer process sends a signal to val writer. So whenever it sends a signal to val writer, what will val writer will do? Val writer writes val data from
Val buffers to the val files.
val buffer to val files. Okay. Once this is done, it sends a signal to what? Where? It sends a signals to BG writer.
Okay.
Okay. It sends a signal to BG writer. When it sends a signal to BG writer, BG writer writes corresponding dirty data from
Shared buffers to the disk.
shared
Data
buffer to
files.
disk or data files. Okay, this is what's going to happen. Okay, check pointer. What it will do? whenever there is a checkpoint happens, checkpointer sends a signal to val writer stating that then the val writer writes this val data from val buffer to the val files. Okay. Now, then it will send a signal to the BG writer. Now the point here, the important point is it will not write entire dirty data. Whatever the val data that has been written from val buffer to the val file, the corresponding dirty data. Okay, only the corresponding dirty data from the shared buffer, the corresponding dirty data from the shared buffer will be written to the disk. Okay, this is about the checkpointer. So with this, we have completed the mandatory background process. Now we will be discussing about the optional background process. One of the optional background process is archiver. One of the optional background process is archiver. Okay. This
Yeah.
is same in the context of Oracle. Okay. Archiver. Okay. So what val writer is doing? Val writer is writing val data from val buffer to the val files
Val
in
files.
PG underscore val location. Okay. So these
Yeah.
val files will be overwritten. Okay. These val files will be
Yeah.
what will
Overwritten
happen?
based on
These val files will be overwritten based on some
LRU
age or
algorithm.
something. Yeah, based on some LRU algorithm or age of the val file, these val files will be overwritten. If you want to preserve these val files, then we need to enable the archive mode. Then we need to enable the archive mode. Whenever you enable the archive mode in Postgres, archiver process, okay, archiver process is responsible for archiver process is responsible for copying the val files from PG underscore val location to the one of the
Archive
archiving
location.
destination. One of the archiving destination. One of the archiving destination. One of the archiving destination. Okay, archiver is a process which writes val file from which picks up val files from the PG underscore val location and write those into the archiving destination. And here it follows an interesting thing. Okay, what archiver will do, right? So generally, val writer writes val data from val buffer to the PG underscore val
Yeah.
location and the file name will be file name dot ready. Okay. Will you be able
Okay.
to see that file name dot ready? No. It is internally it has updated the header of the file saying the file name will be like file name dot ready. Whenever you enable the archive mode, archiver process will go to PG underscore val location. Archiver process will go to PG underscore val location and it's check do we have any files with file name dot ready status. File name dot ready
Okay.
status. File name dot ready status. If it finds any files with file name dot ready status, it picks up those files and copy these files to the
Archive location.
archive location and this file name dot ready and this file the corresponding file name dot ready will be updated with file name dot done. So
Okay.
whenever you see like files with a file name dot ready, which means it is ready to be archived. Okay. Whenever you see any file with file name dot ready, which means it is ready to be
Copied from
archived.
page wall to the archive
Yeah.
location.
It is whenever you see any file with file name dot ready, which means it is ready to be archived, and this file will be copied from PG underscore val location to the archive location. Once the copy is done, then the file name dot ready will be renamed. Then the file name dot ready will be renamed to file name dot ready will be renamed to file name dot run, which means it is archived. Okay, which means
Okay.
it is archived. This is how the archiver process will work. Okay, see. Okay, nothing is there here. If you want, I want to show. Okay, so
I
this
have a
archiver
doubt.
is a this archiver is a optional background process. We can enable or disable by default. It is in a disabled mode. If you want to enable, you can enable. And whenever you enable, then archiver process comes into picture and it will go to PG underscore val location and checks do we have any files with file name dot ready status. If
How
it
to
finds any
enable?
files with archive mode, yeah, that I'll tell you. So if you enable if you enable the archiver, it will go and check do we have any files with file name dot ready. If it finds any file with file name dot ready, it will pick up those files and
Copy to the
it will
archive location.
Yeah, archive destination. Okay. So and once that that is copied, then the file will be renamed from file name.ready to the file name.done. How
Done.
can we enable the archive mode? So if you want to enable the archive mode, okay, if you want to enable the archive mode, there is a command called archive underscore command. Archive underscore mode, archive underscore mode should be on, and there is a command called archive underscore command, and there is another parameter that you need to change is archive underscore command. Archive underscore command, what you will mention is like, so cp, okay, cp percentile p, and cp percentile, cp is a copy command of the Linux, okay, cp percentile p, then archive location slash percentile f. Okay, this is how you will enable the archive mode. cp percentile p archive location slash percentile f. Now what does it mean by percentile p, and what does it mean by percentile f, that we are going to discuss. Percentile p resolves, okay, percentile p resolves to pg underscore, sorry, percentile p resolves to pg underscore val slash file name. Okay, pg underscore val slash file name. If you want to, if you want to understand more clearly, okay, I am in pg underscore val location right here. I am in pg underscore val location, and you give ls. So let's say pg. So this entire location, okay, this entire location, percentile p refers to this entire location slash this file name.
Okay.
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 Okay, this pg underscore val refers to the entire location, including file name, whereas percentile f refers to resolves to what? Only
File.
resolves to only file name. So the
Okay.
file from pg underscore val to this file name will be copied to which location? Archive location, and the file name will be as is. Percentile f refers to the file name. You got it right?
Okay.
So you need to
Yeah,
enable
yeah, got it.
Yeah, you need to enable two parameters. One is archive underscore mode, and second one is a archive underscore command.
Command.
Okay. So
Okay.
whenever you
Okay.
enable this, archive process will come into picture. Now the next topic, now the next process is stats
One
collector.
doubt, one doubt
Yeah.
in this archive. So,
Mhm.
if we have, if val buffer is generating multiple val files, but it's
Mhm.
not moved to archive location destination.
Mhm.
So,
Mhm.
generally, that val file will follow the LRU algorithm, right?
Yeah, until or unless this val file is copied, then the archive val files will not be removed if the archive mode is enabled.
So in that scenario, are we going to in real time if this val location is getting filled up and
Yeah,
in
yeah.
we don't
You
have
will get this
the
kind of issues. Then whenever you get this kind of issues, no, you need to log in and you need to check why the file is not getting copied. There might be some situations right there. So might be that location got, so if that archive location is a shared folder, I mean like shared mount point. Sometimes that mount point will be demounted, right? Unmounted, right?
Mm.
So you need to check why the file is not getting copied. If you you can go to the Postgres log file and you can check why the file is not getting copied. There the error will be written, right? Sometimes what will happen, permissions will be revoked.
like on what basis these files will be moved from val file location to the archive location? Is there any time limit?
Move for moving.
Huh.
For moving, there will be no for time with that. I told you, right? The archiver will go on frequently. It will go on check. Do we have any files with file name that ready? Whenever it finds the file name with file name that ready, it will pick up this file and it will copy the file.
If it's having multiple files which are in
Yeah,
ready state,
it will check each and everything. It will check each and everything. Every
uh,
file.
yeah, like is there any situation we get to know in real time, like val file location is filled up with
Yeah,
900%?
that's what I'm telling you. Let's say you kept a archiving location which is not accessible due to some reasons, might be a permission denied issues or something will happen, right? Archiving destination. When it is
Uh-huh.
not able to copy, whatever the val files that were not copied will not be removed. They remain in the pg_val location. When the files are remaining in the pg_val location, it is going to occupy more disk space.
Okay, okay.
The issues may be anything. It can be a permission enhanced issue, or it the whatever the shared mount that you have mounted will be like, sometimes it will be like unmounted. Some issues will be occur, right? Might mostly it will be due to some permission issues and kind of things will happen during that time. If the archiver is not able to copy these val files from pg_val location to the archiving location, the files from the pg_val will not be removed. They will be remain as is till the archive copies these val files from pg_val location to the archiving location. So at that time, what will happen? pg_val will be having more val files, and the disk, the underlying mount point will be gets filled up.
Okay. In
Now, in that
Oracle,
case, what
we
you need
have
to do,
one
right?
more solution to avoid, like if val
We
file,
don't have.
like we can
We
create
don't
the
have. We need.
soft link, and we can move the val files to some other location, and we can create the soft link so that the val file location will get freed up, and the archive wall will also fetch that
Yeah,
location.
the solution is depending upon the problem actually. So you need to identify the root cause, then you need to fix this.
Okay. Yeah, we can
Okay.
also do in this way, right? It also checks the soft link path also, right? If you
Yeah, it
move.
will check.
Okay.
Yeah, it will check. Yeah, that depends on the see the thing is, till yesterday it is able to copy the files to the archival location. Now only you got the issue. When you
No,
got
it's
the issue, now you
copying.
should
I
be
mean
able to
to say,
identify the root cause.
no, it's
You should be
still
able to identify the
copying.
root cause, right? Uh,
Yeah, I mean to say it's copying, but because of the more IOs in database level, it's getting
uh.
occupied. More logs are getting generated
Yeah,
in that
see,
scenario.
the thing is, that's what I'm telling you. The thing is, though it is, see, in the Oracle also, we have a concept of online redo log files, right? If the
Yeah.
number of IOs are more, do you see any overhead while copying the online redo log files to archive location? Have you ever seen any overhead? No, right? Likewise, though IO is high, which means to say, like, if it is a OLTP database, online transaction processing
Mm-hmm.
database, the number of operations are more, then the redo log generation also more. When the redo
Yes.
log generation, though the redo log generation is more, the archiver will be able to copy the files from